This video, we will study the equation of motion for the case of general plane motion. When a rigid body is subject to external force and coupled moments, it can undergo both translational motion and rotational motion. This combination is called general plane motion. If we're using an XY coordinate system, the equation of motion about center of mass G at point G is maybe written as the following. This equation, that is the scalar equation, is composed of summation fx equal to max and summation fy equal to may, and summation moment about point G is equal to ig alpha. And sometimes may be convenient to write the equation, the moment equation about point P instead. Okay, so that equation of motion are written as follow. It's composed of summation fx and summation fy. It's same. Okay, but for the moment is equal to summation moment about point P. That is equal to summation kinetic moment about point P also. That in this case, kinetic moment about point P represent the sum of moment of ig alpha and mag about point P also. Okay, and for this case, we have the particular case that we should understand. Okay, if for the case of frictional rolling problems, when analyzing the rolling motion of wheel cylinders on this, it may not be known if the body roll without slipping or if it slides as it rolls. For example, consider a disc with mass of m and the radius of the disc is equal to r, subject to a known force P at the center, like as shown in the picture on the left. Okay, the equation of motion for this problem becomes we found out the summation fx equal to magx. Okay, so we set up the axis here like the positive sign convention, and summation fy equal to magy, and also if we checking a moment about point g, we have summation mg equal to ig alpha. But for the force, because the it is not the smooth surface. Okay, so we have the friction force F. Okay, and for now we assume that it has a motion to the right. Okay, the friction force has to opposite to the motion. So then we assume this should move to the right. So friction force should have the direction to the left instead. So according to this, we can form the equation of motion in x direction. That's become P minus F equal to mag. And for summation Fy, it is equal to N minus Mg, it becomes 0. And for summation of moment about point G, okay, we have F times R. Okay, we set up this direction as the positive one. Okay, and alpha is have the same directions of the positive sign convention also. So we have three equations like this, but we have four unknown that's composed of the friction force F, okay, Ag, okay, the normal force, okay, the angular velocity, okay. That is we have four unknowns, but we have just only three equations that is cannot solve, right? Okay, so we have to make an assumption to provide another equation. Then we can solve for the unknown. Okay, the fourth equation can be obtained from the slipping or non-slipping condition of the disk that we may assume. For the first case, if we assume that no slipping occurs, for this case, no slipping occurs. It means that this point, this point, here this that the point of contact of the wheel with and the floor is the instantaneous point of zero velocity. Okay, if we remember that point. Okay, so then at this point, if we consider here as this point, okay, and we can use AG become alpha R. Okay, so for this case, if we assume that this rolling without slipping, we can assume AG equal to alpha R. Okay, the derivation of this assumption you can consult in the detail from the textbook. Okay, as the first case, if we assume that it has no slipping, okay, we said we assume we can use this equation that is AG equal to alpha R. Okay, and the fourth equation, this is the fourth equation, and we keep in your mind that we cannot use here. Okay, and after resolving, we have to verify the assumption also that is correct or not. Then we check the friction force that's after resolve the equation. It is satisfy this condition or not. If it's less than the maximum, this is a maximum static friction. Okay, if it's less than the maximum static friction, it means that our assumption is satisfied. Okay, so for the case number 2, we assume that it has a slipping case. So then we use the friction force is equal to mu kn. Okay, as the fourth equation. Then we will find that Ag will not equal to alpha R anymore. Okay, so for this case, we have this is as the fourth equation. So then we can solve the problem already. Okay, so let's take a look this example. For this example, 80 kilogram roller has a radius of gyration. Now the problem give us the radius of gyration. From the radius gyration, we can determine for the mass moment of inertia, because we know that Ig equal to mkg squared. Okay, and it is pushed forward with a force of 200 Newton as shown in the picture. Okay, we would like to find the angular acceleration. Okay, and we know that the static friction coefficients of the roller and the floor is equal to 0.12, and the kinetic friction is equal to 0.1. Okay, so according to this, we now determine this is the problem of general plane motion, because the wheel has the combination in both translation and rotation. Okay, so then it's become the general plane motion. Okay, so we starting with determine the mass moment of inertia of the roller according to the given value radius of gyration. We can determine for Ig is become 2.45 kilogram meter square. Okay, and after that we consider the equation of motion. We consider the free body diagram here. Okay, and we set up for the dynamic case, we have to set up the positive sign convention, positive axis first. Okay, and this case, we assume that we set up x and y axis here, and then we assume the motion to the positive x, and also the angular acceleration we assume here at the positive 1. Okay, and according to this positive sign convention, we will form the equation of motion. Follow this. Okay, when we consider the free body diagram, okay, it's composed of the weight of the wheel and the apply force here, 200 Newton. Okay, we have normal force and we have the friction force. The friction force now we don't know its direction at first, and so then we assume that if we push the wheel in this direction, we try to push the wheel to the left, so then it means that the friction uh, has the direction of the friction force uh, always opposite to the motion. So then for this case, we assume that the motion is to the left. Okay, so the friction force should be to the right. Okay, according to the positive sign convention here, we form the equation of motion. Follow the positive sign convention, that is to the right as a positive one. We starting with the summation fx equal to 0. We found out fa minus 200 cosine 40 is equal to 80 ag. Okay. Summation fy is equal to na minus the weight. Okay. And also minus 200 and sine 45 degree. And this becomes 0. And now we consider the summation moment about point G, that is summation mg equal to ig alpha. When we taking the moment about point G, we assume the positive direction according same as the positive sign convention that we set up. Okay, so then we found out the moment from friction force should be the negative, that is minus 0.2 FA. 0.2 is come from the radius of the wheel, that is 200 millimeter, is equal to 0.2 meter. And for IG, we already know that it is equal to 2.45 times alpha. Now we have for unknown, that is FA, AG, NA, and alpha. Okay, we need another equation. Okay, that's for this case. Okay, we have three equations already. Okay, we assume that for this case we starting assume with the wheel is not slipping. Okay, so if we assume that the wheel is not slipping, so then it means that we can set up ag equal to r alpha. Okay, r alpha, that's now r is equal to 0.2 and alpha. Okay, so we substitute ag equal to alpha here. After that, we have 1, 2, 3, and also 4 equations now. Okay, with 4 unknown, we can solve the unknown. So solving for these 4 equations, we obtain Na is equal to 926.2 Newton. Okay, Fa is 61.4 Newton. And it is a positive. Positive is mean that it is same direction as we assume, that is Na is upward, and Fa is to the right as we assume. Okay, but for alpha we found that it is a negative value. Negative signs mean that alpha is equal to 5.01 radian per second square, but it is not clockwise. It should be counterclockwise here. Okay. Same as the acceleration. Acceleration is equal to -1. So it means that it's equal to 1 meter per second square. We assume that AG is to the right at first, but now it is negative. So it means that it should be the correct direction should be to the left. Okay. This is for the case that we assume that it is no slipping. Okay. So we have to check. Okay, we have to check our assumption it's no slip. Okay, so if it's no slip, so then we found that we can determine Fa is equal to 61.4 Newton. We check with the maximum static friction, that is mu s times Na, that is become 111.1 Newton. So this means that it is less than the maximum static friction. So it means that the wheel is not slipping. Okay, it's not slipping as we assume. So the solution that we obtain is already correct. Okay, so let's complete this problem.